In this video, we're going to take a look at two applications of right triangles. In these two examples, we're going to look at angles of elevation and angles of depression. So applications of right triangles mean that we're going to have word problems that when we draw a picture of it, it's going to result in a right triangle. So we have Horseshoe Falls on the Canadian side of Niagara Falls can be seen from a small boat 250 feet downstream. The angle of elevation, which is the angle between the horizontal and the line of sight when an object is above the horizontal, from the observer to the top of the Horseshoe Falls is 4 degrees. How high are the falls? So we're given the diagram that we have the boat here. It's 2,500 feet away from the falls, and angle of elevation is the line of sight. If you're looking above, it's from the horizontal to above is 4 degrees. And what we're trying to find is the height of the falls. That's it. We don't have to solve the whole triangle. So we take a look at what we have and take a look at what we're trying to find. We have a right triangle. We have an angle that's 4 degrees. We have the side adjacent. And we're looking for the height, which is the side opposite. So, it's in relation to the angle that you have. So opposite 4 degrees is h, adjacent to 4 degrees is the 2,500. So the trig function that uses opposite over adjacent is tangent. So we set up an equation, the tangent of 4 degrees is equal to opposite, which is h, over adjacent, which is 2,500. Then we can solve for h. So in this example, we multiply both sides by 2,500. So 2,500 times the tangent of 4 degrees is equal to the height of the falls. So on our calculator, 2,500, make sure you're in degrees, times the tangent of 4 degrees is equal to 174.8 if we're rounding to the nearest tenth. So our height is approximately 174.8, and it's measured in feet. My math lab might ask you to round to the nearest foot. If they do, that would be about 175 feet. Okay. Next example is angle of depression. We have the Goodyear blimp is 1,850 feet above the ground and south of the Rose Bowl in California during a Super Bowl game. The angle of depression, the angle between the horizontal and line of sight when the object is below the horizontal, of the North Goal line from the blimp is 58.5 degrees. How far is the observer in the blimp from the goal line? So now we have our picture of the Goodyear blimp. Its vertical height above the ground is 1,850 feet. Here's our right triangle. Line of sight from the Goodyear blimp to the opposite sideline gives us an angle of depression from horizontal of 58.5 degrees. That means that this vertical angle here has to have a sum of 90, that's 31.5. Or you can also think about it as this angle down here is 58.5 degrees. Okay, so that's more of an angle of depression from horizontal. So that angle is 58.5. We have 31.5, and we have 1850. And what we're trying to find is how far the observer is from the goal line. So here's our value that we're looking for. You can use either angle, it doesn't matter. If we use the 31.5 degrees, I'm going to use this one. Then we have the side adjacent, and we're looking for the hypotenuse. So remember, the hypotenuse is always the longest side, it's not the adjacent. So what uses adjacent and hypotenuse is cosine. So the cosine of an angle is equal to the adjacent over the hypotenuse. So the cosine of 31.5 degrees is equal to the side adjacent, which is 1,850 feet, divided by the hypotenuse, which is what we're looking for, the distance d. So to solve multiply, cross multiply, or multiply both sides by d. I get d times the cosine of 31.5 degrees is equal to 1,850. Divide both sides by the cosine of 31.5 degrees. These cancel, and d is approximately whatever I get when I take 1850 divided by the cosine of 31.5 degrees. So I end up with 2,000. I'm going to go to the same number of decimal places that I was given. That's the nearest foot. I'll write down 2169.7 feet. If I round that to the nearest foot, it's about 2170 feet. All right, so those are two examples of using right triangles. You'll have other questions that are not just angle of elevation and angle of depression, but the solving is the same. Draw a picture, label what you have, label what you don't have, and then use a trigonometric function ratio to solve.